All right, today we are going to be talking about real numbers, which, yes, there are things that are not real numbers. Now, today we'll be identifying some things as not real numbers, but we're not going to be actually dealing with or using any numbers that aren't real. You will when you get to high school, however. There are things called imaginary numbers that you will use probably in Algebra 2, Pre-Cal, and Calculus. But today we're going to learn to determine if a number is rational or irrational. We do have 3 vocabulary words. The first number is irrational number, which an irrational number is a number that cannot be expressed as a ratio of 2 integers or as a repeating or terminating decimal. Our next one is a real number. A real number is a rational or an irrational number. And the last one is density property. The density property just basically says the property that states that between any 2 real numbers, there's always another real number. Now, what does that mean? That means like there's a number between 1 and a half. Okay, that's what it's saying. There's a bunch of numbers in between there, but it's saying there's always be another real number. All right. This slide, you don't have to write down this whole thing. Mostly what I'm concerned with is the rational numbers. Okay, write rational number down and then copy down these examples. That way you have examples of rational numbers. But it says, recall that a rational number can be written as fractions. Rational numbers can also be written as decimals that either terminate or repeat. And it gives us an example of our rational numbers. 3 3/4 right here can also be written as 3/8. 2/3 can also be written as 0.6. That goes on forever. The last example here says the square root of 1.44, which the square root of 1.44 is 1.2. All of those are rational numbers. Okay, which is important because today we're going to be working on identifying our rational numbers. Any question on what a rational number is? No? Okay. Then let's take a look at our next one. Our next slide is talking about irrational numbers. This is pretty much the definition that you already have, so you don't have to write this down. You can write irrational number. You don't have to write down this whole the square root of 2 thing. But that is an example of an irrational number, and I'll tell you why. It says an irrational number can only be written as decimals that do not terminate or repeat. If a whole number is not a perfect square, then its square root is an irrational number. For example, right here, the square root of 2. Well, what is the square root of 2? Well, I don't know. I know that 1 times 1 is 1, and 2 times 2 is 4. So the square root of 2, it tells us right here, this little squiggly equal sign means about. Says it's about 1.41421356237309504888016 ... Now, what does that mean? No, that means that it's non-terminating decimal. It means it goes on forever. Okay? That's what makes it irrational. Now, this box right here underneath, it says caution. It says a repeating decimal may not appear to be repeating on a calculator because calculators show a finite number of digits. Now, that means that on a calculator, it'll only show you so many digits, like 10 or 12. I don't even know how many ours will show, but that's all that it'll show. But it's possible that could still be a repeating decimal. What it's saying is the square root of 2 right here. If we went all the way down here to where the dots were, well, let's say instead of dots, it went back over here and did 41421356237309504888016. Again, that would be then considered a repeating decimal. Yeah, sure, it repeated 20 digits. But that's what it's telling you. It's telling you be careful. Okay? Now, are we going to have anything like that on your homework today? No. So you don't have to worry about that. It's just saying in the future. All right, let's take a look at our next slide. Now, on this one, I would like for you to copy down this box because this is important. Okay? This one says a real number, the set of real numbers consists of a set of rational numbers and a set of irrational numbers. These nesting box right here tell us what each of these things are. Okay? It tells us that whole numbers are also integers that are also rational numbers. Okay? So if you have a number that today on your homework that you label as a rational number, it also has to be an integer, and it also has to be a whole number. Actually, let me rephrase that. A whole number has to be an integer and has to be a rational number, but a rational number does not have to be an integer or a whole number. I know that's confusing. I apologize. That's what this is telling you. Okay? If you label something a rational number, that means it's also an integer and it's also a whole number. If you label something an integer, then it is also a whole number. And if it's not a rational number, then it has to be an irrational number. But all of these things are real numbers. Okay? So, and a refresher, remember a rational number is a number that's written as a ratio. It could be written as a ratio of comparison of two things, typically a fraction or decimal. Remember, an integer are all whole numbers and their opposites, meaning negative whole numbers. That would be an integer. Okay? Integers are all whole numbers and their opposites. And the last one we have here is whole numbers. Whole numbers are just positive whole numbers. Okay? And again, an irrational number, remember an irrational number is one of those square roots of 2. It's not a perfect square. All right, let's take a look at our first couple of examples. The first three says write all the names that apply to each of these. Well, let's look at the square root of 5. Okay? The square root of 5. What is the square root of 5? No, it's not 2.5. 2.5 times 2.5 is 6.25. No. The square root of 5, there's not a square root of, or there's not one you can do in your head because, remember, it's not a perfect square. 2 times 2 is 4. 3 times 3 is 9. So it has to be in between there somewhere. But we don't know what it is. And because of that, this has to be an irrational number. I don't know. We don't care. All we know is that it's irrational. Well, not necessarily. Like 49. I mean... anyways, yes, that's what the answer. That's what the paper's asking you for. This would be an irrational number, and it would also be a real number. Yes, ma'am. No. Just write irrational. Gosh, you guys are the laziest people ever. It's like yesterday, whenever y'all were whining because y'all had to write 5 words. Are you saying? Yes. Can I say hi? No. Anyways, let's take a look at letter B. Letter B, we have to identify all of the names that apply to this. So what is this going to be? Well, I know it's negative 12.75, but is it irrational? Is it rational? Yeah, this one is going to be rational because it's a decimal. Okay, and what else? It's also real, yes. Is there anything else it could be? It can't be an integer because, remember, integer has to be a whole number, and they're opposite. Can't be irrational because, because it's rational. No, it can't be an integer. We just had that conversation. It can't be an integer because it's not a whole number. Remember, a whole number or an integer are whole numbers and they're opposite. So it can't be an integer. Well, it is a decimal. That's why it's rational. That's not even a choice. All right, let's take a look at letter C. Letter C says the square root of 16 over 2. Well, what is the square root of 16? Yeah, so this would be like 4 over 2, which is the same thing as just 2. Okay, so what are all the names that would apply to this one? Yeah, it's going to definitely be rational. It definitely is going to be real. Well, because a rational number can be written, remember, as a ratio. which could be 4 over 2 or 2 over 1 or something like that. But what else? Yes, it is an integer. What else? Yes, this one is actually all 4 of those because it's rational, it's real, it's also an integer, and it's also a whole number. Because when we simplified it, we got 2. If you didn't simplify it, you may not realize that, say, it is a whole number, or that it could also be an integer. All right, questions on that one? No? All right, then let's take a look at this one. Someone asked me, yes, ma'am? Now, letter D, I've had several people ask me what, at least last period, well, what's going to be a not real number? If all of our things are real, then how do we have a not real number? Well, let's take a look at letter D because I'm going to spoil the surprise for you, but letter D is not a real number. Now, why is it not a real number? Yes, sir? Yeah, it's negative inside your square root symbol. Well, how do we have, what is the square root of negative 4? What number times itself equals negative 4? Well, what's negative 2 times negative 2? Positive 4. What's 2 times 2? That's also positive 4. It's impossible to multiply a number times itself to get it to be negative. Okay? So, well, you can have negative 2 times 2, but then you're not multiplying the number times itself. Okay? So, letter D right here, this is going to be not a real number. Sure. That is not a real number because it has a negative inside your square root symbol. That will be fine. Okay? Now, let's take a look. But that's going to be your dead giveaway, that negative right there. Okay? Let's take a look at, well, letter D, one more time. If the negative was in front of your square root symbol, that would be okay. Okay? Because, yeah, it would be real because it just means whatever the square root is, that's going to be negative. Okay? Letter E. What is the square root of 4 ninths? What's the square root of 4? What's the square root of 9? 3. So, yeah. Okay, so what are all the names that are going to apply to this one? Real. It's going to be real. Yeah, this one is rational. No, it's not going to be an integer because, remember, an integer has to be a whole number, and they're opposite, and this obviously isn't going to be a whole number, so I think that's probably going to be all of them that apply to this one, real and rational. It's not an integer. Remember, an integer has to be a whole number. No. Rational numbers are fractions. That is the last example we have. But let's real quick talk about the questions towards the bottom of your page. Number 15, 16, and 17. Those are the ones that are talking about the density property. Okay, I know we talked about that property. It was in your definitions. But if you look at number 15, 16, and 17, it says find a real number between each pair of these numbers. Now, how do we do that? Well, look, on number 15, it gives us 7 3/5, and it also gives us 7 4/5. And it's asking us, what is a number Right here. What's a number in between 7 and 3/5 and 7 and 4/5? 7 and 3.5/5? No, actually that probably would work, but no. How do we do that? Well, we can find these already have a common denominator, but we could make this 7 and 6/10, and we could make this one 7 and 8/10, because all I'm doing is multiplying these guys by 2. Now, what's numbers in between those? Yeah, 7 and 7/10. That would be in between your 3/5 and your 4/5. And no matter what number they give you, there's always a number in between them. It doesn't matter if it was 7 and 3 over a million, and then 7 and 4 over a million. Well, we could find 10 million, and then we could find something else in between. Okay? Yes. Well, if there's different denominators, find a common denominator. Okay? But that's how we apply the density property. Okay? That's what it's talking about. All right, questions on that? No? All right, then let's get to work, please.